Welcome to Sir RP's channel. In this video, you're going to learn how to solve equations transformable to quadratic equations. Are you ready to learn? Sit back, relax, and get ready to learn. For our session, we have this most essential learning competency. The learner solves equations transformable to quadratic equations, including rational algebraic equations, and solve problems involving quadratic equations and rational algebraic expressions. Let us first define unsimplified equations. These are equations whose terms are written as product of factors and or whose like terms are not combined or simplified. For example, we have the quantity of x plus 1 squared equals 20 minus the quantity of x plus 3 squared. It can be simplified as 2x squared plus 8x minus 10 equals 0, which is a quadratic equation. What are we going to do? We need to solve for x plus 1 squared and also the quantity of x plus 1 cubed. And then simplify that, the result would be 2x squared plus 8x minus 10 equals 0. Let's have the first example. You write the quantity of x plus 2 squared plus the quantity of x minus 1 squared equals 9. Then solve for the values of x. Just like the example I presented a while ago, we need to solve for the square of a binomial first, and then we need to simplify for us to have the standard form of a quadratic equation. With this, here is the solution. The quantity of x plus 2 squared plus the quantity of x minus 1 squared is equal to 9. Solving for the product of quantity of x plus 2 squared, we will get x squared plus 4x plus 4, while for x minus 1 squared, we will have x squared minus 2x plus 1. Then copy equals 9. Then we need to combine like terms. X squared plus x squared is 2x squared. Then positive 4x minus 2x, that is positive 2x. 4 plus 1 is 5 is equal to 9. Then we need to apply the addition property of equality. We have 2x plus 2x squared plus 2x plus 5. This is positive 9, so this will be negative 9. And 5 minus 9 is negative 4. So we now have our standard form of the quadratic equation given the original equation, that is the quantity of x plus 2 squared plus the quantity of x minus 1 squared is equal to 9. After that, solve for the values of x using the different methods in solving quadratic equation. Okay, so we have 2x squared plus 2x minus 4 equals 0. In this process, I applied factoring. I simplified first the given equation by dividing each term with 2. That is 2x squared divided by 2 plus 2x divided by 2 minus 4 divided by 2 and 0 divided by 2. So from here, we will have x squared plus x minus 2 is equal to 0, and find the factors of x squared plus x minus 2 equals 0. We have x minus 1, that's the first, and then the second quantity of x plus 2 is equal to 0. Applying the zero product property, our final answers are 1 and negative 2. That's for our first example. For unsimplified equations. The next equation that we are going to transform into quadratic equations will be rational algebraic equations. These are equations consisting of rational expressions. For example, we have 1 divided by the quantity of x plus 1 plus 2x divided by x minus 1 is equal to 2 over x squared minus 1 is a rational algebraic expression where x is not equal to 1 or negative 1. By algebraic manipulation, this rational equation can be transformed into 2x squared plus 3x minus 3 equals 0, which is a quadratic equation. Again, our goal first is to transform the given rational algebraic expression into the standard form of a quadratic equation. From this equation, we now have our standard form of a quadratic equation. How? Let's have an example. Rewrite 6 over x plus x minus 3 over 4 is equal to 2, then solve for the values of x. Again, our goal first is to transform this into the standard form of a quadratic equation. What are we going to do? Here are the steps. First, simplify the rational algebraic equation by multiplying both sides by the LCT of the expression. And with this, we can say that the LCD is for x. That is for x times the quantity of 6 over x plus x minus 3 over 4 is equal to 2 times 4x. 4x times 6, it's 24x. This is the result. 24x over x plus 4x times x minus 3, that is 4x squared minus 12x all over 4 is equal to 2 times 4x is 8x. Then you need to simplify. 24x divided by x is 24. 4x squared divided by 4 is x squared. Negative 12x divided by 4 is negative 3x equals 8. Then you're going to write it in its standard form. From here, we have x squared minus 3x. By addition property of equality, we will also have negative 8x plus 24 equals 0. Simplify negative 3x minus 8x, that is negative 11x. Therefore, our standard form of a quadratic equation is x squared minus 11x plus 24 equals 0. The next thing that we need to do is to solve for the values of x. We have here, by factoring, we have x squared minus 11x plus 24 equals 0. The factors are the quantity of x minus 3 and quantity of x minus 8. And by applying the zero product property, we have 3 and 8. For the process on how to solve for factoring, please check the other videos I uploaded regarding solving quadratic equations using factoring. That's for rational algebraic equation. Again, we have already had unsimplified equations, rational algebraic equations transformed to quadratic equation. And the last one is the higher order polynomial equations. These are equations of higher degree, especially those whose degree is greater than that of quadratic equation. This means again that the degree is greater than 2 because the degree of a quadratic equation is 2. Examples: x to the 4th power minus 4x squared plus 25 equals 0 is a polynomial equation of degree 4 because the highest degree is 4, or the highest exponent is 4. So that is degree 4. Second, 2x to the 6th power minus x cubed plus 3 equals 1 is a polynomial equation of degree 6. Looking at the highest exponent, that is 6. We are going to solve for the values of x by transforming this equation into a quadratic equation. How? Let's have examples. This lesson will focus on higher order polynomials whose exponents of the variables are divisible by 2. By substitution, the given polynomials are transformed into quadratic equations as follows. We let certain value be equal to x squared for the equation x to the 4th power minus 4x squared plus 25 equals 0 for us again to have a quadratic equation. So in here, we let the value of u be equal to x squared so that when we substitute, since this is x to the 4th power, that is composed of two u's, okay? Because u is equal to x squared and another u is equal to x squared. U times u is u squared, but when we try to translate that, that is just x to the fourth power. Okay, u squared minus 4u plus 25 equals 0. Take note that our value of u here is x squared. For the second one, it's 2x to the sixth power minus x cubed plus 1 equals 0. And here, we're going to use x cubed instead of x squared because again, we're trying to transform this into a quadratic equation, which means we're going to have a degree of 2. Okay? Considering that this is 6, okay? Let us divide this into 2. That is 3, right? So we are considering x squared as the value of v. Okay? 2v squared minus v plus 1 equals 0. Again, this v is just x cubed and the other v is also x cubed. When we multiply x cubed times x cubed, that is just x to the sixth power. Again, we need to transform the higher order polynomial equations into quadratic equations. For example, rewrite x to the fourth power minus 4x squared plus 4 equals 0 as quadratic equation. Take note that the degree is 4, right? The highest exponent is 4. Therefore, we need to let a certain value, it's either u or v or any other variable, be equal to, what do you think? It's x squared. We'll let u be equal to x squared. From here, that is just x to the fourth power minus 4x squared plus 4 equals 0. Then we simplify that since our value of u is x squared. So x squared squared minus 4 times x squared plus 4 equals 0. We substitute the value of u. Okay, so that is u squared minus 4u plus 4 equals 0. Therefore, the quadratic equation form is just u squared minus 4u plus 4 equals 0. That is how we rewrite the higher order polynomial equation into a quadratic equation. Let's have another example. We will solve first for the quadratic equation in standard form and try to find the values of x, considering the example x to the fourth power minus 6x squared plus 9 equals 0. So from here, we let u be equal to x squared to transform the given polynomial equation into a quadratic equation. The same process as I presented a while ago, that is x to the fourth minus 6x squared plus 9 equals 0. Since u is equal to x squared, we substitute x squared with u, that is u squared, plus, that is u squared minus 6u plus 9 equals 0. That is now our quadratic equation in its standard form. Then solve for the value of u using any applicable method. By factoring, we will get u squared minus 6u plus 9 equals 0, and the factors are quantity of u minus 3 and the quantity of u minus 3 is equal to 0. So that is just u minus 3 squared equals 0. Therefore, by applying zero product property, our value of u now is 3. Okay. After this, you now go back to its original equation. We remember that u is equal to x squared. And after solving for u, we had the value of u equal to 3. So from here, since u is equal to x squared, therefore, x squared is just equal to 3. Solve for the value of x. Take the square root of x squared and 3. Square root of x squared is x, while square root of 3, considering that the value is greater than 0, so it can be a positive and a negative square root of 3. Now our values of x are positive square root of 3 and negative square root of 3. That is how we transform higher order polynomial equations into quadratic equations. We first transform and then solve for the values of x. And we always remember the original variable, which is x in this example, by substituting it with a variable, for instance, u, as used in this example. For this time, let us start to check. Again, our most essential learning competency is the learner solves equations transformable to quadratic equations, including rational algebraic expressions, and solve problems involving quadratic equations and rational algebraic equations. That ends our session for today. For your practice, answer these two problems. Transform 2x times 5x minus 1 equals the quantity of x plus 1 squared minus 10 into a quadratic equation in standard form. Number 2, solve for the values of x in the equation 1 over x plus 6 is equal to 1 over x squared. For your answers, please use the comment section. Once again, thank you and happy learning. Thank you, Quipper, for the slides used in this presentation. Don't forget to subscribe and click the notification button to receive updates. This is Sir RP.